Module 4, Lesson 13, Writing Division Expressions. Now you might have noticed in the last few lessons that we've worked on that you haven't seen division. We've seen some multiplication, we've seen some addition, we haven't played much with subtraction. A lot of what we've done with addition can be applied to subtraction, but division, of course, becomes this whole different thing to work with. So learning targets here show and explain the relationship between the operations for specific and general situations. Not going to look as much at that learning target today. Represent real life situations, not looking as much at that. We are going to be comparing expressions, and it's not so much comparing expressions as we are going to be looking at different ways to write division expressions. Alright, so I can statements. I can write a numerical expression to represent division using two forms. We have dividend, and we have our traditional division symbol with divisor. But we are really going to be moving into expressing division as fractions. It's a more, if you want to think of it as powerful or more simplistic or easier way to think of it, especially as we start working with more complex expressions and equations. Moving to expressing division as fractions is going to be powerful. And an explanation of the relationship between the forms of division. Alright, so we have some ways we can write 8 divided by 2. I obviously mistiding an animation there. So pause and think, what are some different ways you can show or write 8 divided by 2? And here are a few possible answers. Got the traditional form here. We've got it written kind of in words. This is a fraction form, and this is also a fraction form. And we could also model it 8 split into 2 groups, or we could do 8 split into groups of 2. So we have models for our two meanings of division. Now, thinking about these different models and different ways of writing division, when working with algebraic expressions, so when we start plugging in some variables, are any of these expressions or models going to be more efficient than others? Are they going to provide us with a greater level of flexibility? I'm pretty sure that models are not going to be terribly flexible. They're great for understanding conceptually what's happening, but they're not great for flexibility. I'm pretty sure that we have already worked on writing things in the simplest possible way, and I'm pretty sure that writing things out with words is not going to be extremely efficient, so we can probably eliminate that. So that leaves kind of our traditional form here, and then our fraction form. And as I said before, we've got two ways to write the fractions, kind of the traditional over the top of each other, but then we also have kind of a typing method here. This is probably the easiest way to put fractions into computers, and so we need to recognize that as a fraction. You might remember in a prior lesson, once upon a time ago, we looked at the division symbol and we actually observed that the division symbol is a fraction. Numerator, denominator, and a fraction bar. When we're starting to work with algebraic expressions, the fraction form is really going to be our most flexible and powerful way of working with division. And we're not going to show a ton of examples today to really show off that power. You're going to have to take it on a little trust at this moment. But writing a fraction is going to be very powerful, and it's going to make working with algebraic expressions a little bit simpler, a little bit less confusing. So today we're going to work on writing division in fraction form. Before we go too far, we need to stop and think about the meaning of the parts of division. And to help us with that, we're going to pose the question, is 8 divided by 2 the same as 2 divided by 8? Now, hopefully your brain is screaming at you, no, that is not the same. But just in case your brain isn't saying that to you, let's take a quick look at some models here. If I've got 8, and I divide it by 2, I've made two equal sized groups. Remember, that's one of our interpretations. Or I've got 8, and I have put it into groups of 2, 2, 2, and 2. So I find that I can make 4 groups or 2 groups of 4. Well, let's stop and think about 2 divided by 8. So let's say we've got 2, and we are going to put it into groups of 8. Now that's kind of a mind puzzler here. Well, to have a group of 8, we're going to need more 2's. See if I can get my brain on track this morning. So here's my 2, and I want to have a group of 8, so I'm actually going to have more 2's here. A group of 2, a group of 2, and a group of 2. But I only have 2, so I only have 1/4 of a group of 8. So if I'm going to take 2 and put it into groups of 8, I've only got 1/4 of what I need. The other way to think of this is we are going to take 2 and we are going to put it, we're going to cut it and make 8 groups. So there's 2. Now, I've cut it in half. I've got 2 groups, and each group is worth 1. And if I cut again, now I've got 4 groups. Got 4 pieces, and each one of them would be worth, my brain is having a horrible time this morning. Let me start that over and see if I can figure that out. All right, I'm going to draw a different model because my brain is really struggling here. I've got 2. I'm going to cut it into 8 pieces. 1, 2, 3, 4, 5, 6, 7. The 2 is cut into 8 pieces, and the question is, how much is each of those pieces worth? Well, 4 pieces will make a 1, and 4 more pieces will make a 1, because there's 2, so I've got my 2 whole 1's here. And then I am looking at one single piece, and each piece is worth 1/4 of 1. So big, long explanation using models, but 8 divided by 2 and 2 divided by 8 are not the same thing. 8 divided by 2 yields a 4, and 2 divided by 8 gets us a 1/4. So it's important we remember in division that we cannot change the order of the parts. We really like multiplication and addition because we can change the order. 2 plus 3 is the same as 3 plus 2. 5 times 9 is the same as 9 times 5. With division, 8 divided by 2 is not the same as 2 divided by 8. It's important that we remember the parts of division are not interchangeable. We actually use words dividend and quotient and divisor. The quotient is the answer. The dividend is what we have. The divisor is how we're going to split it up. So showing a divided by b using a fraction. We've already looked at this. We could show it as a slash b. We could also write it as a over b. All right, so write an expression showing 1 divided by 2 without the use of the division symbol. And we're going to walk through some steps for how to do this because we really want to get this ingrained in our heads, so we do everything with models. So let's start by looking at a model of 1 divided by 2. So we need to, in our heads, be thinking, okay, how am I going to show 1? And then I'm going to split it into 2 pieces. So I've got 1 here, and it has been split into 2 pieces, and we are asking, what is the value of each of these pieces? Well, each of these pieces represents half of the 1. So from this model, we can see that 1 divided by 2 is the same as 1/2. To find this part of the diagram, we did 1 divided by 2. And this part is the same as 1 divided by 2, which gives us 1/2. So write an expression showing a divided by 2 without the use of the division symbol. Well, here's our a, and we have divided it by 2. So looking at our model here, what are we going to write? Now this is very, very similar to the last problem. Well, we have a, and we have divided by 2, and a is divided by 2. Each of these pieces is a divided by 2. And so each of them is a divided by 2. We can figure out that a divided by 2 is the same as a halves. So the parts of a division expression when we write it with the division symbol. So we're going to touch base on some of the vocabulary here. This is the dividend. This first part is the dividend. This is the how much we have. The divisor gives us information about how we are going to split it, how many groups we're going to make, or what size of groups we're going to make. When we write these as a fraction, they look like this. The dividend is the numerator, the divisor is the denominator. Or, writing it in a horizontal form, this is a vertical form here, here we are writing it horizontally, the dividend comes first and the divisor comes second. So write an expression showing a divided by b without the use of the division symbol. Well, it would be very helpful to think about what we just learned in examples 1 and 2 to help us with this example. Before we did 1 divided by 2, and we did a divided by 2. The 1 and the a are the dividend, so they were the top number. The 2 and the 2 were the divisor, so they were the bottom number, the denominator. So we should be able to say to ourselves, the dividend is the numerator, divisor is the denominator. So we should be able to write a divided by b in the form of a over b, or a divided by b. This fraction bar means division. All right, so now we can start to stretch ourselves, work with things a little bit more complex. We're going to write an expression for g divided by the quantity h plus 3. Now we need to read this carefully. We need to think about what is going on here. We need to think about what is supposed to happen first. Well, it says g divided by. So in my head, I'm thinking to myself, g must be the dividend. And I am thinking the rest of this must be the divisor. And if I were to write this in the regular form with the division symbol, I would write g divided by h plus 3. But my brain is screaming at me, I'm supposed not to divide by h, I'm supposed to divide by h plus 3. So I need to make sure that I put some parentheses in there to indicate that I'm supposed to add the h and the 3 together before g is divided by them. So now I can ask myself, okay, I've got this dividend, I've got this divisor, how could I write that in a fraction form? Well, g divided by h plus 3. And here we start to see a little bit of the power of the vertical fraction form. We don't have to use the parentheses on this bottom part. By writing it in the fraction form, I don't have to put in the parentheses saying do the h plus 3 first. Part of the fraction form says that I'm supposed to do the h plus 3 first. If I wanted to do g divided by h and then add 3, it would look like this. So already we're starting to see a little bit of the efficiency of writing in this vertical form. Now the tricky part is when we type things in computers, frequently, well, let's face it, it is not very easy to do this vertical form. So if we were to write it in a horizontal form, we would put g, and we could use that slash, but we would still have to use the parentheses h plus 3. So even though we will encounter this horizontal form, it is not as efficient as writing it in the vertical form. So with the division symbol, it would look like this. Rewrite it as a fraction. So here's our vertical form, and here is our horizontal form. I want you to be familiar with both of them, which is why I'm making sure that we look at both of them and we talk about each of them. All right, so here we have, write an expression for the quotient of the quantity m reduced by 3 and 5. Now this is a nice good one for us to think about. So the first thing we need to do is ask ourselves, how would this look with the division symbol? So I have the quantity, I'm finding a quotient, so I know there's a division problem. And I'm looking for the quotient of the quantity m reduced by 3 and, is the division symbol here, 5. So there it is with the division symbol. Now hopefully your brain is saying to you that you better add some parentheses, because we're supposed to reduce m by 3 before we divide by 5. Now that we've got it written with the division symbol, we can start to ask ourselves, how would this look in fraction form? Well, the m divided by 3, sorry, the m minus 3, the m reduced by 3, is the numerator. The 5 is the denominator. And once again, I don't have to use parentheses because this, all of this, is divided by this. Once again, showing some flexibility. If I were to write it in horizontal form, I would have to put in the parentheses, just to make very clear that I'm not doing the 3 divided by 5 first. So with the division symbol, having thought it through very carefully, written as a fraction, notice that I don't have to do the parentheses over here, but over here I do. All right, so take a moment and think your way through these exercises. And when you're ready, go ahead and continue the video, and you'll be able to see my work if I manage to hold it together. So it says division symbol and fraction. 12 divided by 4, which is 12 over 4, or 12. All right, there we go. 3 divided by 5. 3 divided by 5, which is 3 divided by 5, which is 3 divided by 5. So on these non-algebraic, or on these simpler problems, there's not a huge difference with what's going on. It's when we start getting into some of the more complicated problems that we start to see the advantages. So remember, we've looked at how it can be helpful. All right, a divided by 4, a over 4, a, because on these, let's face it, it doesn't look like one of them is really more efficient than the other one. But if you think back to the last couple of examples where we had multiple operations going on and we didn't have to put parentheses in, that's where you start to see some of the real power. The quotient of 6 and m. Now we start to see some of the power here on E through H. Boy, I had a rough time making this slide presentation. I'm going to have to go back and make several corrections, so thanks for bearing with me. All right, 7 divided by the quantity x plus y. So I have the quantity of x plus y, and I have 7. So I've got 7 and the quantity of x plus y, and 7 is divided by that quantity. So it's important that I put the parentheses in because I need to do the x plus y first before I have 7 divided by it. And then I can have 7 divided by x plus y. And if I wanted to write it horizontally, 7 divided by x plus y. Y divided by the quantity x minus 11. So y is divided by the quantity of x minus 11. So y is divided by x minus 11, and y is divided by x minus 11. The sum of the quantity h and 3 divided by 4. So I've got divided by 4. What is divided by 4? The quantity h and 3. So h plus 3 divided by 4. H plus 3, going to have to put some parentheses here, divided by 4. The quotient of the quantity k minus 10 and m. So I've got a quotient here, and I've got the quantity k minus 10, and I've got m, quantity of k minus 10, divided by m. I'm running out of room. Didn't leave a lot for myself. We'll erase some of that last problem. And I've got k minus 10 divided by m. And all my k's are sloppy. And k minus 10 divided by m, but don't forget the parentheses. All right, so take a moment and discuss with a neighbor how you would rewrite any division problem using a fraction. Well, the dividend is going to become the numerator, and the divisor is going to become the denominator. I am going to think about where I may or may not need parentheses. All right, so a quick look at the I can statements here. Hopefully by now you can write numerical expressions to represent division using two forms. Hopefully you can write it with the regular form, and hopefully you can work with both of these fraction forms. And hopefully you can explain the relationship between the forms of division. The dividend becomes the numerator, and the divisor becomes the denominator. The fraction bar is the division symbol. All right, so a little bit of comparing expressions here as we have written division in multiple forms and worked on recognizing that the forms are equivalent to each other. 4 divided by 2 is equal to 4 divided by 2. All right, that concludes Module 4, Lesson 13. So make sure you pay attention to your problem set. If you've got questions, make sure you talk to your teacher, seek out some help.